Welcome to Succeed e-learning app. Today we are going to learn about probability. So what is probability? Probability is the possibility of occurrence of an event. You have seen several examples in class 9 already. For example, tossing a coin. So we have seen an example where a coin was tossed 1000 times and we ended up getting 455 heads and 545 tails on the series. Which means we had got 455 heads out of 1000 tosses. That is, the probability of head is 0.455. Now, the probability of tails was given as 545 tosses out of 1000, which is 0.545. So this is based on the experimentation. So this can also be called as empirical probability or experimental probability. So this can vary from person to person or from experiment to experiment. You may get 355 heads and rest of them as tails and so on. So several mathematicians across the world perform this experiment in order to understand what are the number of heads and tails in the experimental probabilities. They have found out several solutions. So as the time passed by, they started experimenting more, like 10,000 times, 1 lakh times, 10 million times. As the experiment kept going, the number started to settle down at a particular point, that is 1/2 or 0.5. So this is nothing but the theoretical probability of tossing the coin. In the next section, we are going to see what is the theoretical probability and how the ideal conditions will be assumed while resolving those situations. Calculating probability using theoretical approach. We have already seen how tossing coin experiment gave different results across the world. This is because it was experimental. So theoretically, we tend to assume everything as equally likely opportunity. For example, tossing a coin can give the head as an outcome as much as it gives tails. Let us ignore the coin landing on its edge because this event might occur only when it lands on sand or similar surfaces. Let us consider another example, that is rolling of die. For us, a die is a fate die which provides the equal outcome in all its throw. That is, as you know, die has 6 numbers, 1, 2, 3, 4, 5 and 6. So we consider that when we roll a dice, there is equal chances or opportunities of each of these numbers representing or coming out. Similarly, let us consider a bag which has 4 red balls and 1 blue ball. Now, let us assume that one of us will go pick a ball by closing her eyes. Now do you see the possibility of red ball occurring as many times as blue ball? That is, are they equally likely to occur? No. The equally likely opportunity need not occur in all the conditions or in all the situations. Therefore, only in the theoretical probability calculation, we consider the situation is equally likely. In class 9, as you remember, the experimental probability or the empirical probability was calculated by using the formula P of E is equal to total number of trials in which the event occurred divided by the total number of trials. Now, in this chapter, we are going to define the theoretical probability, which is given by P of E is equal to number of outcomes favorable to E divided by total possible outcomes of the event E. Let us look into some questions to understand theoretical probability better. Question number 1. Find the possibility of getting a head when a coin is tossed once. Also, find the possibility of getting a tail. Now, you have already seen that the possibility of getting a head is 1 and possibility of getting a tail is 1 when you toss a coin. Now, total number of possible outcomes is 2. That is, it can either be head or be tails. Here in the question, they have asked us to find out the probability of getting a head. So now you know that the total outcomes is 2 and the possibility of getting head when it is tossed once is only 1. So if you have to sum it up, the probability of getting a head is 1 out of 2. If you write it in terms of formula, we know that formula for the theoretical probability is given by P of E, where E is the event. Here E represents the event of getting a head as an outcome. So this could be written as P of head is equal to number of outcomes favorable to E, which is nothing but the number of times we get the head, divided by number of all possible outcomes. All possible outcome is head and tail. Therefore, when you write it, we get it as 1 divided by 2. Similarly, if F is the event of getting a tail, as you already know that there is a fair chances of getting a head and a tail. So head is 1 and tail is 1. Therefore, P of F or P of tail is also equal to 1 divided by 2. Topic, that is impossible events. Now, let us calculate what is the probability of getting a number 8 when you throw a single die. Also, what is the probability of getting a number less than 7 in a single throw of a die? Now, answering sub-question 1, we have been asked to calculate the possibility or the probability of finding a number 8 when we throw a die at once. So, is it practically possible? A die will have 6 numbers, that is 1, 2, 3, 4, 5, 6. Now, if I am rolling 1 dice, I can get any number between 1 and 6 and not a 8. Therefore, probability of getting a 8 is equal to 0 possibility of getting 8 divided by the total outcomes, that is 6, which is equal to 0. So, such kind of events are called as impossible events. Now, let us move into the sub-question 2. It says, what is the probability of getting a number less than 7 in a single throw of a die? So now they have asked possibility of getting a number less than 7 and not less than equal to 7. So less than 7 can be 1, 2, 3, 4, 5 and 6. We will see how we are going to calculate that probability here. So in this case, the total number of favorable outcomes is as same as the total number of possible outcomes, because we want to calculate what is the possibility of getting a number which is less than 7. So there are 6 numbers divided by total number of outcomes is 6. So 6 divided by 6, which gives us 1. So the probability of getting any number between 1 to 6 within a dice when you throw it once is 1. So, the probability of an event which is sure or certain to occur is always 1. Such an event is also called as sure event or a certain event. Now, note that from the definition of probability P of E, we see that the numerator, which is the number of outcomes of which is favorable to the event E, is always less than or equal to the denominator, that is the number of possible outcomes. Therefore, we can generalize it as P of E is somewhere between 0 to 1. Also, it can be written as 0. So, this can be written as 0 less than or equal to P of E is less than or equal to 1. Harpreet tosses 2 different coins simultaneously. Say one is of rupees 1 and the other is of rupees 2. What is the probability that she gets at least one head? So this is the question. Now let us look into the solution. We write H for head and T for tail. When 2 coins are tossed simultaneously, the possible outcomes are H, H or H, T or T, H or T, T. That is, both of them can be head or both of them can be tails, or one can be head and the other can be tail. Also, one can be tail and the other can be head. So these are the different combinations of getting a possible event, that is head and tail, when you toss two coins simultaneously. Now the question is, you have to find the probability of she getting at least one head. So how are we going to find that? Now in the combinations that we discussed, there are three combinations where it has at least one head, that is H, H has two heads, so the criteria here is at least one head. Now H, T and T, H. So there are four possible outcomes. Now the question says we have to find the probability of getting at least one head. Therefore the head up can be three possibilities. Now similarly, H, T means head up on the first coin and tail up on the second coin. The outcomes favorable to the event E, that is at least one head, are H, 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 T and T, H. So the number of total favorable outcomes is 3 and the number of total outcomes which is possible is 4. So this can be written as probability of getting at least one head is equal to 3 divided by 4. That is, the probability of Harpreet gets at least one head is 3 divided by 4. Now you can also find P of E as follows. That is, P of E is equal to 1 minus P of E dash, which is equal to 1 minus 1 by 4. So what is this 1 by 4? 1 by 4 is nothing but probability of getting all tails and no head. So there was one possibility, that is T, T, where we got all tails. So that is nothing but 1 out of 4 outcomes. Therefore this can be written as 1 minus 1 by 4, which is 4 minus 1 by 4, that is equal to 3 by 4. So you have now learnt how to find the answer in two different ways. Two dice, one blue and one grey, are thrown at the same time. Write down all the possible outcomes. What is the probability that the sum of two numbers appearing on top of the dice is 8, 13, less than or equal to 12? So we have 4 sub questions in this question. Now the first question says we have to write down all the possible outcomes. Now we have been given with 2 dice, that is one blue dice and another one is grey dice. So when the blue dice show 1, the grey die could show any one of the numbers, that is 1, 2, 3, 4, 5 and 6. In the same fashion, when the grey dice shows 1, the blue dice can show any of the 6 possible outcomes. So there could be 6 into 6 possible outcomes, which is 36 possible combination. Now let us see how we are going to list it down. This would be a lot easier if you write it in the matrix method. Now on the x-axis, write down one dice, let it be grey dice. On the y-axis, write down another dice, that is grey dice or a blue dice. Now this can be written in the matrix method. Now let us place one die horizontally and one die vertically on a plane. So we know that the total number of possible outcomes when you throw one die is 6. Let us write all the numbers horizontally, that is 1, 2, 3, 4, 5 and 6. On a similar fashion, let us write all the 6 possibilities vertically. Now we are going to pair these two in order to get the possible outcomes. So let me consider one on the left hand side, which is on the vertical column, and match it up with the horizontal written numbers, that is 1, 1, 1, 2, 1, 3, 1, 4, 1, 5 and 1, 6. Similarly, if you fill it up all the other numbers or all the other rows in the given matrix method, you get the following table. These are the different possible outcomes when you roll 2 dice simultaneously. Note that the pair 1, 4 is different from the pair 4, 1. So, the total possible outcomes is equal to 6 into 6, which is 36, as I already told you. Now, sub question 1. The outcomes favorable to the event, the sum of the two numbers is 8, denoted by E, are 2, 6, 3, 5, 4, 4, 5, 3 and 6, 2. So, when you sum these two numbers, you have to get 8. That is how we found it. That is, the number of possible outcomes which is favorable to E is 5. Therefore, this can be written as 5 divided by the total number of outcomes, that is 36. Now, moving on to the sub question 2. As you can see from the figure, there is no outcomes which is favorable to event F. The sum of two numbers is 13. So, P of F is equal to 0 divided by 36. The maximum that a dice has is 6. So, the maximum possible number which can occur when both the dice are simultaneously rolled is 6, 6. When you add it up, you get 12. So, there is no possibility of getting a 13 when you roll 2 dice. Next, moving on to the third sub question. As you can see in the figure, all the outcomes are favorable to the event G. Sum of two numbers which is less than or equal to 12. Therefore, P of G is equal to 36 divided by 36. When you cancel it out, you get 1. That is the solution to the question. We have come to the end of the session. So, let us quickly see the summary of this unit before we wind up. In this chapter, you have studied the following points. The difference between experimental probability and theoretical probability. The theoretical or classical probability of an event E, written as P of E, is defined as P of E is equal to number of outcomes favorable to E divided by number of all possible outcomes of the experiment. The probability of a sure event or certain event is 1. The probability of an impossible event is 0. The probability of an event E is a number P of E such that 0 is less than or equal to P of E is less than or equal to 1. An event having only one outcome is called an elementary event. The sum of the probabilities of all the elementary events of an experiment is 1. For any event E, P of E plus P of E dash is equal to 1, where E dash stands for not E. E and E dash are called complementary events. I hope you enjoyed learning with us. For more such videos, keep watching Succeed e-learning app.